Tim. I don't know how many of you saw me yesterday do the, okay, good. So you have a fair idea of what it is that I do. That was the live version. The bread and butter of what I do is this YouTube channel. This is the current iteration of it. It's called Acapella Science. It covers a host of different science topics. Just on this front page, you've got the arrow of time and entropy, chemistry, string theory, evolutionary development biology, the CRISPR system for gene editing. So it's sort of pitched at a fairly high level, but the conceit of it is that I'm using popular songs or classic songs, remixing them in a cappella form and using them to explain some sort of topic in science. So what's in this talk? I'm going to tell you a little bit about just who I am, how I came to be doing what I'm doing. I'll talk about this sort of edutainment phenomenon on YouTube, which is kind of this new generation of creators that are springing up really just out of the ground, it seems. Just anyone who has an interesting idea can go on YouTube now. So we'll talk about that. We'll talk about how to make a good science parody, but also more generally how to make science art and sort of my thinking on what makes art work and then what makes art work as a medium for science communication. And then we'll ask, does it actually work? And that's the part where I would love your feedback, actually. I started music very young. This is me playing the fake guitar and the real piano at the age of 3 years old. It's my dad teaching me. And then I also started with science with Bill Nye the Science Guy at the age of, I think a preschooler introduced me to that. And right away for me, the groundwork for my future career was seeded because Bill Nye, at the end of every one of his videos, had a song, a science parody song. I think the band was called Nerdvana, and this was their Air Pressure song. I grew up in a forest. If you can see my house is that black spot in the trees. That's all you can see of it. And I didn't go to school until grade 10. I was homeschooled before that. So taught by my mother, but mostly by myself. Which is how homeschooling tends to work, right? It's like go get some books and learn about it and then write a thing and then learn something else. And so I think that's weirdly prepared me for this modern internet age where you kind of have to be doing everything all at once, especially in my career, because I'm a very one-man show. But more generally, I think it kept me open to all sorts of different possibilities. Through high school, I had many bad haircuts and much more interest in music. I picked up the drums and also apparently Photoshop. And around that time, the internet was springing up, and for the first time, it was kind of becoming an avenue for expression and art of, the bandwidth was high enough that you could put, various forms of media on there. MySpace became a thing, and almost immediately I started making science music because that's apparently who I am. This was a deep house project called methyl butyrate that I had. And then the metal one didn't have anything to do with science, but I titled it with sciencey titles because I don't know, this is who I am, I suppose. Ended up at McGill University. I did an undergrad in physics and then a master's in physics. Tried my hand at experimental physics at Triumph, which is in BC. It's the particle accelerator at UBC, and I was terrible at it. But while that was happening, I was good in physics, but experiments, forget it. I have very shaky hands, and I spill things everywhere. So about, 2006, YouTube came on the scene. And almost immediately, YouTube is a very different medium than, say, MySpace was pretty, it was this explosion of artists who could all of a sudden be known, but it was almost entirely musicians. And music is a much more restricted format, but video can be just about anything you can imagine you can do on a video, right? And so almost immediately you saw people starting to use YouTube for, well, all sorts of things that had never been seen before, partially, science communication. So this is one of the first ones, Minute Physics, who was a real big inspiration to me. This is my first YouTube project. It was called Cabin 9. It was just me and my friend doing music. Don't look it up. It's still there, but It's not good. But this is how you learn, right? You learn by doing, and I started with things like this, and while I was doing my degree, I was doing as much work on these silly YouTube projects as I was actually doing any sort of research. And then science music comes up as YouTube, and as YouTube grows, we get into more niches. This is the thing about as your base expands, you can kind of support stranger combinations of things. So one of the earliest was Alpine Cat. This was the LHC rap. And then people started doing these really interesting a cappella videos on YouTube, which I think this is a brand new medium. Like, I don't think this ever existed on VHS tapes, this kind of like one-person a cappella project. This is Mike Tompkins, one of the first guys who really inspired that. And then came along a really interesting group called the Maccabeats. I don't know if any of you guys ever saw their work, but the strange thing about them was I had this interest in a cappella, and I had this interest in science, and the Maccabeats came along, and they were doing basically what Mike Tompkins was doing, really high-quality a cappella music you could just listen to. But it happened to be entirely about Jewish history and Jewish holidays. So they had this song, I don't know if you remember that song, I throw my hands up in the air sometimes. They did, I flip my latkes in the air sometimes, singing Ayo, spin the dreidel. And it was all about Hanukkah and like the history of the Maccabean revolt, and I didn't know about that, but all of a sudden I was fascinated because it was, these guys singing it in a catchy song. And I guess a light bulb went off for me. I thought, well, if they can make me care this much about history, maybe I can do this for science. And then, of course, I had been super into Weird Al, who's the original, the OG parody artist that everyone must pay homage to, and Bill Nye the Science Guy, the other big inspiration. And then, so this is the summer of 2012, and the Higgs boson was announced, the discovery of the Higgs boson at CERN. And I watched the live stream of that at about 3 in the morning and started writing these parody lyrics to Adele's Rolling in the Deep. And so spent about 6 weeks producing that video and didn't really think it would go anywhere. I made a new channel for it. I advertised it to the 300 people who were subscribed to me on the old YouTube channel. And I thought this would be fun for my colleagues. And instead, it got picked up by the news. It got put in newspapers in Germany. I guess this 2012, this sort of thing was still news to have like a viral video. And then I finished my master's degree, and there's my thesis. You can go and read it if you want. It's about universes that don't exist. So I don't know how applicable it is to everyday life. And soon after that, I released my second video, Bohemian Gravity, which Rennie referred to. And that one was really the one that launched the YouTube channel and made me think, okay, there's something here that people are really connecting with, something about this combination of the science and the a cappella. And the thing is, I still felt like I was kind of bad at it, right? And so over the course of the last 6 or 7 years, I've been going through this kind of iterative process of trying to figure out, what is this thing? How can it be the best thing that it can be? And I think I have some ideas of what's going on now, of how to do this properly. So I'm going to see if I can share some of them. But the first thing that I want to say is, obviously, I'm not alone in this. There's a whole group of us who seem to, like when I talk to other people in the circles, they seem to have very similar backgrounds of sort of strange free childhoods and interests in disparate subjects, and we all wind up on YouTube with some sort of strange creative idea. So this is like, obviously the edutainment idea is not a new idea. This is, you can go very far back on it, and obviously things like Carl Sagan and National Geographic and magazines and books and museums, like we're all working in this space of like taking science and making it into entertainment, and we all I think it's all pretty much the same idea, which is sometimes it's boring to just learn. Let's figure out a way to add the other elements of the human experience into it. Even like musical science parody, I've traced it back to at least the late 1800s. I don't know if it goes further back than that, but people were, doing, at Bell Labs, people were writing whole parodies of Gilbert and Sullivan plays based on their work. And Tom Lehrer, who wrote the Elements song, also parodied Gilbert and Sullivan. They seem to be popular. So this is not a new thing to, educate and entertain at the same time. But there are some particularities. Oh, sorry. There are some definite particularities to the YouTube version. And I think the best way to sort of show you how this generation is doing this edutainment thing is to just show you a few examples. So I'm going to give you 3 examples. This first one is Vihart, who's a math explainer and one of the first people to ever do this. So that's Vihart. You can, fast-paced, irreverent. Here's another one that came in a few years after. This is Bill Wirtz with his video, The History of Japan. I think this is about a minute of it. The video is 10 minutes long, and I promise you the whole thing is like this. So that's Bill Wirtz, bit of a fire hose of information. One more I'm going to show you. This was a fellow that I actually just met last year. He's exploded off of YouTube basically in the past year. His name is Patrick, and he runs a channel called Tear Zoo. And his essential conceit is explaining the entirety of the natural world as if it's an online video game. All right, so that's Tear Zoo. So I don't know if you understood what he was saying there, but I promise your students would have. So there's a few things that a lot of us seem to have in common here in this creative YouTube space. One is that as I said, we mostly spring up independently. These aren't things that are generally started by organizations or the BBC or whatever. It's just people in their bedrooms who have this new technology to make things entirely by themselves, and they start making it and putting it on the internet, and it finds its own audience. And the internet is large enough that very weird things can network together and find a small audience that's distributed around the entire world in a way that didn't used to be possible. It's irreverent. You will notice that Bill Wirtz is not shy of using curses. Vihart is not shy about expressing her dislike of most of mathematical education. This is the internet. We are, we're still in the days of coming out of the Wild West, but still a more irreverent style. We're competing with cat videos, as I said. So these videos tend to be very fast-paced. People on the internet are consuming information at a very high speed. And so, in your feed on YouTube, you'll have this, and you'll also have some vlogger who's talking a mile a minute, and you'll have the latest exploding SpaceX shuttle and all sorts of other things. So if we want to compete in that space, we end up being very flashy and just like a barrage of information. The advantage of this kind of medium is that if you miss something, you can go back and watch it again. So I've watched that Bill Wirtz video about 10 times, and now I think I'm probably pretty good at explaining the history of Japan to people, at least on that level. And then it's, again, with the internet, it's pop culture, it's meme culture, it's showing, like Tear Zoo is doing, it's showing that you're part of these communities that already exist. So Tear Zoo is really focused on the gamer world and showing that whole group of people, hey, I'm one of you, and let's talk about zoology in this language that we all understand. Nevertheless, so those are the new things, but there's definitely some things that don't change in science communication and education generally. One of them is the structure of information, right? Like if you're going to present information, you can't just fire facts at people and expect them to retain them. We don't have random access memories. We conserve memories in structures, and so the two main structures that I think about are like a knowledge tree where you have core ideas and you're branching off of that and building up something that you could almost reconstruct from its core principles, and then the narrative structure of a story. So if you want people to conserve information, you put it in a structure like a tree or a story. As Joe Hansen says, a lonely fact is a fact that will fail. The other conserved thing is if you want people to retain information, you relate it to something that they already know. You don't try to build up something from scratch. You branch it off of something that they're familiar with, something they already have intuitions for. This is Diana Cowan, physics girl. She's really good at this sort of thing. So this is a video on the left that's explaining various aspects of three-dimensional rotational mechanics using skateboards. And then on the right is the physics of ultraviolet and sunscreen, which everybody puts on, but nobody really understands how it works. So relatable content. And then the third thing that I think we've all discovered is that all of us are best when we do precisely what interests us most. So, look inward and see what you're passionate about, and then explore that. That on the left there is the bullet cluster, which is one of the most fascinating images that I've ever seen. It's a depiction of, well, it's a photograph of the dark matter having separated from two galaxy clusters after they collided. So the pink is the actual matter, or the normal matter, and then the blue is the dark matter having gone right through and not interacted, whereas you can see that bow shock. So I find that incredibly fascinating. I'm thinking about doing a video on it. I haven't yet, but I know that it's going to be something that I can push and really, truthfully engage with people about. The internet is very much about honesty and about expressing what how you truly feel about things. So know thyself. So for me, what I'm passionate about is music and science. So I'm going to say a little bit about how to make good science art. How am I doing on time?
Pretty good right now.
Pretty good? Okay. You got what, half an hour still?
You got about, 25
okay,
minutes.
perfect. So science art. I would see anything like what I'm doing as a handshake. There's a respect that needs to occur on both sides. Especially if you're more on one side than the other, it's very good to go in presuming that you have a lot of work to do to get up to speed. So a scientist who goes into art needs to understand that people study art for 10 years before they get good at it. And an artist who tries to approach science needs to understand the same thing about science, right? So it's not like you have to be an expert, but you need to respect both of them, and I think that shows when it comes through. So I thought I'd give you a couple examples of how this can go, not wrong, but not what I'm going for, at least. This is what I would call one-sided handshakes, where you have someone who's way on one side or way on the other side. And here's what results. So the first one would be if you're an artist stepping into science. So that's the classic Thomas Dolby, she blinded me with science. You didn't learn a lot of science from that video. The science in this video, it's not meant to be actual science. It's meant to be aesthetic, right? Thomas Dolby is putting on like the clothes of a scientist and sort of parodying what a particular cultural idea of the scientist in order to talk about something totally different, which in this case is how he feels about a girl, presumably. On the other side, we have people who are more on the science side and then step into art, and here's what that looks like. So like, that's really like, I enjoy that video. Like it's a fun video. And but at the same time, I would not put that on my iPod and just listen to it as a piece of art, right? So in that case, the art is the aesthetic. It's something presumably this class is putting on to explain lab safety, and that's the point. So I want to talk a little bit about art and what makes good art, and it's going to be focused on song, but there's a lot of things I think here that apply to a lot of forms of art. So if you're thinking about mixing science and art, you'll get some ideas. I'll talk about story structure, I'll talk about lyrics, and then I won't really get into music because it's just too large of a world for me to put into one talk. But just thinking about art in general, like what I think really makes art work is that it's this kind of fractal, nested, patterned structure that, like, you can look at it from the largest scale and it's interesting and meaningful, and then you can look at it at the very smallest scale and it's very interesting and meaningful. So if you look at something like a great Renaissance painting, you know, you can step back and enjoy the majesty of it, and then you can get 2 inches from and like love not just the people but the individual brush strokes, right? And music, I think, is one of the greatest examples of this, because music is really patterns within patterns within patterns. Like, even if you think about what a tone is, or a harmony, it's a very quick repeating pattern happening maybe 1,000 times a second. And then that structure is built into geometric series of harmonies, and then those harmonies are put together into complicated mathematical polyrhythms of different rhythms and note groupings. And then you build that up into an entire emotionally fulfilling structure of a song that tells a story over the course of it. And then you add lyrics on top of that, and you get into the entire nested structure of poetry. So, you know, individual word choices have a certain sound to them that evoke certain emotions. The phrase has a certain rise and fall to it, and then, you know, the overall structure of the lyrics is also, you know, telling a satisfying story with a point to it. So I think the fundamental thing that I want to say before I get into any of the details is, like, recognizing that art works on all those different layers and thinking about it at all those different layers, instead of seeing it as say, like, I'm going to write a set of parody lyrics, or I'm going to make a drawing. Like, to think about art as this nested structure, I've found really helpful for making sure that I'm making fulfilling art and something that really resonates with people. So let's talk about story structure a little bit. Here's the classic. If you've taken any literature classes in your life, you'll have seen a diagram like this. Is the classic story structure of, you know, the beginning, the rising action through maybe a couple of waves of small climaxes, and then building to a big defining moment near the end and a resolution. You know, it's a story structure that we've seen in many different forms. A pop song, as it happens, has a very similar structure to it. So you'll notice that a pop song tends to start off low energy, goes through a couple waves of rising to a chorus, and then a second verse with maybe a little more nuance in it, a little more things going on. A more interesting chorus, you know, a big build to a final climactic ending, and then a resolution. And I'm not sure why this is this you know, emotional structure that seems to appeal to people, but at least in, like, Western culture, that seems to be the primary mode of storytelling. The other classic one that, you know, you can get into is the hero's journey narrative, right? You start in a place of safety and security and knowledge but comfort, and then the hero is forced outside of their own territory, encounters something new, has to go through some sort of radical change at the bottom of this diagram into the vast unknown, and encounters some changing information that they absorb and they bring back to their starting point, eventually back to their home, but they're changed somewhat. This is a very classic story arc. And there are songs that follow this kind of story arc as well. Bohemian Rhapsody is a good example of one of these. So if you were going to do, say, a song parody of Bohemian Rhapsody, you would want to find something that follows this structure of starting in the known, finding some sort of novel information, having a revelation or transformation, and then returning back to your starting point. And if you think that sounds like a tall order, I think that's basically the entire process of the scientific method and scientific discovery, is pretty much doing that. It's encountering something novel, changing yourself and your theory as a result, and then coming back with your new understanding back to a place of security. So it should be pretty simple, but don't do it with Bohemian Rhapsody, because I already did that, and I don't want the competition. Here's Ed Sheeran, one of the great pop masters of our time. So let's look at his song, The Shape of You. This is a pretty classic, you know, like I said, rising action, verse, chorus, verse, chorus. It's not even so much a bridge, it's just like a repeating plea and then a final chorus. So like musically, this is what's happening. If you just look at the energy of the song, this is pretty much what you would graph out. And then Ed Sheeran is really good at taking that and putting a story to it that fits with this emotional context. So in this case, it's a story about a guy and a girl. They meet at a bar, whatever. They're interested in each other. He has this sort of like excited invitation to her, girl, I know, you know I want your love. Your love was handmade for somebody like me. And then the first chorus, I'm in love with the shape of you. The first chorus is, you know, it is the high point thus far, but at the same time, there's not all that much context for what he's saying. So he gets through that. And then the second verse, there's a little, you know, it's a little more interesting. They're going on their first date. They see that they enjoy similar things. They talk about their families and their lives. And then he repeats the pre-chorus and the chorus. But there's a little more nuance to it now. Like, it means a little more. The same words that he's saying, you know that he's not actually just talking about her physical shape, but he's also talking about, you know, her emotional qualities and her life and, you know, her passions and how they fit together. And then there's a final, like I said, very repetitive, come on, be my baby, come on, be my baby, come on, just over and over and over. And a final glorious chorus where everything comes in and presumably they're now happily together and experiencing, I don't know, the fullness of each other. So suppose you wanted to make a science parody of this song. What I want to do is conserve as much of this structure as possible. Ed Sheeran's already done all the hard work. You know, he's made this masterful song that works on a level that people can grab onto it and enjoy it, that works on a story level where the lyricism matches the story. And so what I'm interested in doing is, like, Mr. Sheeran has already put this pattern in the brains of millions of people. And what I'd like to do is take that pattern and basically do what those, those binding sites with proteins where you've got like a different ligand that still fits in and it competes with the original. This is kind of what I'm going for. So I want to fit my chemistry knowledge into this pattern that's already present in the minds of the world, and then they'll absorb it because the brain goes, oh, that's that song that I love. So how am I going to do that with this structure, with like changing as little as possible to keep everything in place? It's very simple. You make one of them a proton and one of them an electron, and then pretty much everything passes as it should. You have the proton electron, they get together, there's an attraction. You can talk about the initial shapes that they form, but there's not much context to it. But now that they're together, you can explore more of the different ideas of how they work together, the various ways that they can interact. And then when you get back to talking about how they bond, there's more ways that they can bond. You can get into covalent bonds and aromatic bonding, and then finally, maybe you can build up to a glorious ending where maybe you realize, I don't know, everything is made of these particular bonds between protons and electrons, and that's the entirety of the world, is basically this one interaction played out in complicated ways. So I think that might work. Let's find out. So the other thing that I'm doing is, like I said, I'm building from the simple into this sort of tree of outward expanding knowledge. There's one core thing, which is the bond between the proton and the electron, and then exploring the possibilities and building on that core idea. Let's talk about lyrics for a second. This is the LHC rap by Alpine Cat. This is another example of science rap. It goes, LHCb sees where the antimatter's gone. Alice looks at collisions of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. It was another very fun video, but you can also see there's a lot of sort of blank space in this in terms of the lyrical structure. Pretty much she's rhyming the ends of the last syllable. There's one internal rhyme there with LHCBCs that I really like. But if you compare that to a lyricist like, say, Eminem, who's, I think, one of the great lyricists of modern times, you'll see a distinct difference. So I'm going to skip that video, I think. But if you look at Eminem, pretty much every word in his lyrics is doing the work of tying together with other words and giving you something that you can hold on to. So there's all these internal rhyming patterns. The way he does this is by bending the words in order to make them fit better together. So I've sort of color-coded the rhyming words together. His palms are sweaty, knees weak, arms are heavy. There's vomit on his sweater already, mom's spaghetti. And it's like, it gives you this kind of hypnotic feel of like every word in this piece is doing work to hold it together. So if you wanted to make lyrics based on this, well, I did that as well. This was a video about the making of the atomic bomb. So they've armed the weapon, countdown clock is set, and J. Robert Oppenheimer is sweating, eyes are red and he's nervous, but on the surface, because on the surface this is Armageddon. Preserving that whole rhythmic pattern that makes people accept this as, that's that song that I love. The other thing that's important to do in something like this, what does all the work in a pop song is a few like key hooks. So here's an example from Weird Al Yankovic. I hate these blurred lines. You remember that song? The core of Weird Al's song is to take that and make it something that you will accept as that line. So if Weird Al says, I hate these word crimes, and then he goes on to tell you all of his gripes about grammar. Robin Thicke has this, thank you, Robin Thicke, the wonderful line. You the hottest bitch in this place. And this, like, I don't know any of the lines before that one, but I do know that line because that's a line that's meant to stand out, like all the music drops out. And so Weird Al builds an entire verse around that where he says, you would not use its in this case, explaining apostrophes and their proper placement. In The Shape of You, the hooks are, I'm in love with the shape of you, is the core line that you want to get across. So what can we do with this with protons and electrons? Well, how about how molecules take the shape they do? That seems pretty good. Or how about molecules take the shape of you? Because that is in fact true. All you are is a big combination of molecules. Come on, be my baby, come on. How about come bond with me, baby, come bond. If you, like, Ed Sheeran has a lot of internal rhymes in his lyrics as well. 1 week in, we let the story begin. So I might say, 1/2 spin will give a left on a twin. This is, again, I've explained, I'm preserving as much of his artistry as I can. A lot of these things you won't have recognized in the pop song when you listen to it. It just washes over you. This is what art does. It's mostly processed subconsciously. But this is something that a movie reviewer called Mr. Plinkett always says. You may not have noticed it, but your brain did. This is, like, your brain is paying attention to all of these subtleties when you take in a piece of art and you don't even notice it. But it often makes the difference between loving something and feeling, it's okay. Like I said, I don't have much to say about the music. The only thing that I'll say about, like, this is, I would never discourage anyone from making art or science art, no matter how talented or untalented you are. The best way to do it, to learn it, is by doing it. But if you're like a professional organization that's trying to look into something like this, find someone who knows what they're doing musically, because the musicians, I trust you, will be able to tell. So I encounter a problem with my form of art, which is that songs are a very restricted informational medium. Like, for one thing, it's a very difficult puzzle to solve, like lyrics that have all these constraints. But for another thing, a song, especially if it's a flowy song, I will always love you. It took a very long time to get that idea across, and also they repeat that line like 5 or 6 times. So how do you convey sufficient information in this sort of limited bandwidth art? Well, my solution is to not do it with a song, but to do it with a video. Video has far more information coming at you than you can possibly actually interpret. So then the bandwidth problem is not in the art, it's actually in your brain. So you have a certain processing like amount that you can process coming off of a video, and my job is to make sure that I present you with information as fast as you can absorb it, sort of at that that peak between what you can reach and what you can't. So what I'll do is the song will be the scaffold, and then the video will kind of flesh it out. But in terms of what your brain can absorb, here's some highlights from a book by Richard Mayer, I think, or Meyer, I'm not sure how you pronounce it. But you can look it up if you want to. It's called Multimedia Learning. And some of the key ideas that he sort of sorts out in that book are, let's see, so when you're looking at multimedia, you have basically two data streams. You have your eyes and your ears. Your eyes are like, you have a limited amount that you can process with your eyes. With your ears, it's not as much of a problem because it's hard to produce information in an audio stream faster than you can absorb it auditorily, but with vision, it's certainly the case that things can be terribly cluttered. If you walk through the poster session, I'm sure you'll find some examples of that. So you want to keep things simple. You especially don't want to get the language processor fighting with itself. If you've got someone explaining something like in the auditory channel, you don't want people to have to read something different in the visual channel. It doesn't work. Your brain gets very confused and you sort of drop the whole thing. So generally, if you're going to have words on the screen and someone talking, they should be pretty much the exact same words or a summary of what the person is already saying. Mayer has found that graphics and narration work best. If you're going to have text, make it text that fits very closely with the narration. So this is bad. Don't do this. This is me early on trying to shove way too much information into a single screen. And I don't think you can tell that I'm trying to explain the subgenuses of the order of primates. There's too much going on. This is better. This is, a very simple diagram explaining just a few core features of a molecule. And of course, I still cluttered it up because I'm me and I need to put my face somewhere. So that's the general process. So now I'm going to show you the final result of all of that informational work, and you can see what you think of it.
A dot isn't the best way to try to sum up how electrons come and go. They are the states of a matter field that follows an equation the Dirac wrote. The Schrodinger part of the whole equation will just lead in sub C when it expands. Now get that cool thumb and add it in with the proton and watch them start to dance. It's hydrogen, it's like, oh proton, I feel your tug. Central potential, dip down, pulling on me. But I'm not falling in deep. Know that would break uncertainty. Say, oh, electrons move too much. Slow down your pace and put that orbit on me. Come on now, follow my lead. Come on now, follow my lead. Orbitals take the shape they do, the stable states of the quantum rules. And when one approaches two, they combine and they're bonding. Thus hydrogen as a rule is found in nature as H2. Energy configuring a molecule, diatomically bonding. Low, high, low, high, low, high, low, high. Diatomically bonding. Low, high, low, high, low, high, low, high. Diatomically bonding. Low, high, low, high, low, high, low, high. Diatomically bonding. Energy configuring a molecule. When orbitals take the shape they do. One half spin will give a lepton a twin. One up, one down in the ground state. With S&P and quadruple degeneracy, the second shell can be filled up with 8. The higher angular power spread all the beautiful flowers and middle families that come into play. Well, here's a carbon with 6C. This ain't nothing tricksy, but we're gonna make some methane today. With hydrogen, it's like, oh atoms, I feel your tug. Got my electrons plugged out, pulling on me. Come on now, settle around me. I'll hybridize to sp3. Say, oh, carbon, here's our touch. Spread out 109.47 degrees. Come on now, follow our lead. Come on now, follow our lead. Molecules take the shape they do, combining states of the quantum rules. Like when a shell goes sp2 for sigma pi double bonding. And as widely as their purview, they spread out in the molecule. Look at benzene in a ring, they hold it true, aromatically bonding. Low, high, low, high, low. baby, come bond. Come bond with me, 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 baby, come bond. Polymers take the shape they do, combining base level residues like RNAs, ACGU, with their hydrogen bonding. Peptides make a chain and group, and get up lead sheets and corkscrews. With the secondary links they fold and move. They're all over your body. Come bond with me, baby, come bond. Come bond with me. They're all over your body. Come bond with me, baby, come bond. Come bond with me. They're all over your body. Come bond with me, baby, come bond. Come bond with me. They're all over your body. You're a chemical machine, it's best you do. The molecules take the shape of you.
So does it work? Oh, yeah. Do we actually convey information this way? I went to, in preparation for this talk, I went on the internet and asked the people following me, what do they actually get out of this? Like, is it mostly entertainment? Is it mostly education? And I found a few responses. This is not a very scientific study, but a few representative samples which hopefully don't paint me in too much of a unfairly positive light because I picked them. One thing that I found is that this is not a replacement for a curriculum, right? Like, it's not, you can't learn the entirety of science this way. There are some concepts that don't generalize. It's also just like, I'm one person doing this. If I was going to make a whole curriculum out of these videos, it would take me about 200 years. And there's some things that you just need different forms of explanation for. So I see this more as a supplement to like proper forms of education. But sometimes people really do get exposed to an entirely new field, or particularly if I'm presenting something that I know less about, I tend to pitch it a little further down to a more accessible level. So here's someone saying that they learned a lot about gravitational waves. The history video about the making of the atomic bomb was probably a good example of something that is more accessible on the ground level that people can use as a starting point. People are certainly using these in their classrooms. I would love to have an actual study done of the effectiveness of using them in their in the classroom. If anyone here has access to researchers who are interested in that kind of question, get in touch with me. But people are certainly doing it, so I mean, if you want to try it in your own classrooms, you can see if it works. They're definitely partly support structures for people in the sciences, because being in science can get very frustrating and lonely and long, and this is part of building a community that people can come and enjoy this thing together and see, oh, someone put in real time and effort into something that I love and have spent a long time understanding. So people really appreciate that. I find that it's a really good introduction to, from one scientific field to another a lot of the time. So here's a biologist saying that they learn a lot from my physics videos, and a physicist saying they learn a lot from my biology videos, and kind of that idea of, okay, you're not going to go spend 5 years of your life studying this completely other field, but maybe I can give you a quick and easy break from the drudgery of looking at slides under a microscope, and then you can learn about an entirely new thing, right? And then because they have this flashy, hooky quality to them, they're a great starting point. So I get a lot of emails and messages from parents saying, hey, like this parent, my kids now explain the whole field of exoplanetology better than anyone I know, and that was based on a 10-minute Aladdin medley that I did that kind of went through the entire history of that field. My niece is 3 years old, and she's asking her mom, hey, Mommy, what did Einstein do for gravity? And her mom doesn't know, she has to ask me, because Einstein's theories are pretty esoteric. But she thinks of Einstein as that girl in the funny wig, because that's what I did for my video. But it's a starting point for her. She's super curious now about what is going on. And then there is just pure entertainment. But at the same time, who knows, right? Like, most of your processing is happening subconsciously. And so there are some people who just pretty much just watch these videos to have fun. But that is kind of the whole thing that we're doing as YouTubers, is try to convince people, hey, you're just having fun. You're not learning. This isn't work. This is a fun time. And then maybe later, who knows what they'll pick up. I had one person message me and say, I just realized, like, because I'm studying chemistry now, that your first couple seconds of that Shape of You video is Lewis dot diagrams. And I thought that, like, not only is that really cool that they remembered that when they were looking at the lecture, but they're also going to have about 4 more of those moments from that particular video, like, as they go through their, you know, hopefully their budding career as a scientist. So, as I said, I'm not the only person doing this. There's a lot of us on YouTube sort of exploring different aspects. There are people who are focusing on all sorts of subfields like evolutionary biology, music theory, library sciences. There's a whole network of us, and a lot of us are together now on this Slack channel called We Create EDU, where we're sort of collaborating and trying to do things more collectively and share all our ideas and interests. So I would recommend that you follow that on Twitter, We Create EDU, if you are interested, and you know, try using some of our stuff in your classrooms. So I think that's all I have. Thanks to the Canada-wide Science Fair for having me. It's been an amazing experience coming out here. And I guess, do I have time to take questions?
Wait, we're going to defer the questions till a little later. If you're
Okay.
going to be around.
Yeah, sure.
Yep.
Okay, so I guess we'll break or have Rennie, and thank you so much.